Hello everyone. So this video is going to go over some design rules and tips when it comes to designing 3D models that are going to be 3D printed. I'm going to reference this chart. This chart is also available in my classroom. It's also in Schoology. And if you look down on the bottom on the left here, this has different sort of technologies. We are going to solely be focused on this top row. So our 3D printers are called FDM printers, or fused deposition modeling printers. So ignore everything else, just look at this one row right there. It's important to note that our printers have a nozzle diameter, so where the filament comes out, of 0.4 millimeters. And why that's important is if you look at these first two columns here, so supported and unsupported walls, it's recommending a minimum thickness of 0.8 millimeters, which is essentially saying you need at least 2 layers thick for it to be at all doable. Obviously, thicker is better. If you have a thickness between 0.4 and 0.8, so maybe say 0.6 millimeters, that would be 1 layer thick. You can't really have like 1.5 layers thick. It doesn't really work that way. So between 0.4 and 0.8 is 1 layer. If you try to make a wall less than 0.4 millimeters, it won't print at all. It'll just disappear. So imagine like designing a home and say that the walls of the home was 0.3 millimeters. If you go to print it out, you're not going to have a home. It'll disappear. So at least 2 layers thick everywhere, and even that, in my opinion, would be way too thin. It's going to snap off. It may be good for like little models that you're not going to do anything with, but if it's functional, if it needs to do a task, it's not going to be enough. Thicker is better. I will come back to overhangs because that's the most important thing we need to talk about. Embossing and engraving. Zoom in a little bit here. So this refers to elements of your design that are either raised or lowered in the model. So oftentimes you might see someone's name, or a logo, it might be sort of sticking out. That's called embossing. If it's dug into it, that's called engraving. Same recommendations. So they recommend that each feature of like all the different letters or numbers, whatever it is, be at least 0.6 millimeters wide and at least 2 millimeters high. If it's smaller than that, what will happen is that when you go to print, it's not going to look clean. The letters may look kind of messed up. So those are sort of the recommended minimum details. Bridging is related to overhangs, so I'll come back to bridging later as well. Holes, you may want a hole in your design for one reason or another. Maybe you want to screw things together. Maybe you want to hang it on a wall, whatever the case may be. It's recommended that the hole diameter is at least 2 millimeters. When you think about it, it's still very small. You probably don't even want a hole to be that small, but nothing smaller than that. Otherwise, the hole is not going to print cleanly. If you want things to sort of connect and move together, so they have an example of like sort of a peg in a hole. If you want that peg to move freely inside the hole and not get stuck, the diameter of the hole should be at least 0.5 millimeters larger than the peg. Escape holes does not apply to us. That's for different technologies, so we can skip that. Really, any minimum features, it should be at least 2 millimeters thick. Right? Anything smaller than that, again, if it's just like a figurine or something, it may not matter. But anything that's going to be functional, it's just not going to really support a lot of weight. It's not going to work well. It's going to snap and break probably pretty easily. Pin diameters. If you need a pin for whatever reason, maybe you're making a 3D printed car and you need like an axle for the wheels, it's recommended that the diameter of the pin be at least 3 millimeters thick. Anything thinner than that, it's not going to print well. Tolerance, this is a big one. So our 3D printers, they're pretty good, but they're not like, top of the line printers by any means. So this type of printer has a tolerance of about 0.5%. What that means is if you go to design something, say you want it to be exactly 100 millimeters in length, it may not be exactly 100 millimeters. It may be like 99.5 millimeters, something like that. It may vary just slightly. It may not seem like a big deal, and for the most part it's not. When it really matters, and if you come back to the peg in the hole, people often assume if you have a peg with a diameter of 10 millimeters and a hole with a diameter of 10 millimeters, that they should fit snugly one inside the other, and that is not the case. The hole typically gets printed a little bit smaller because it contracts as it cools, so the peg won't fit whatsoever. So you may need to make that thickness of the peg, instead of 10 millimeters, maybe it's like 9.9 millimeters or something like that if you want it to fit nice and snug. And it'll probably involve a little bit of trial and error to get it just right. So that brings us back to our main topic, which is overhangs. So the way these 3D printers work is when they print a model, and you'll see this in class, it starts from the bottom and it prints layer by layer. So it sort of slices the model into a bunch of different layers, and it's important for it to have a layer to print on top of. And if you look at the little diagram here, the magic number here is 45 degrees. All right? So an overhang is something that sort of sticks over, and you want it to be able to print on top of each other. So if I pull up this right here, so this is the slicing software we use for our printers. If you look at the THY, if I were to try and print this, let's do this. So I'll slice this, put it into layers, and I'll start at the bottom. And notice that as it goes up, everything's fine. It's able to print one layer on top of the other, no worries. But then right here, for the H, it's now trying to print this. This is a bridge, all right? It's trying to print this on top of nothing. And when for something like this, if you're doing a bridge, as you see in the chart over here, all right, bridging, if it's about 10 millimeters or less, it will eventually work itself out and be okay. It may not be perfectly pretty, but it'll work. Anything larger than that, though, it's going to start sagging, and eventually the print will fail. Same with the T. All of a sudden, right about here, if you look at my T, it's now trying to print the two sides on top of nothing. And again, it may eventually work, but it's going to start to sag. It's not going to look pretty. If you have really large overhangs, what will happen is the printer will try to print on nothing, and eventually it just fails, and you have to cancel the entire print. So what you don't want to have happen is, print something for like 3 hours, and at like 2.5 hour mark, the print fails, and you have to start all over again. Notice the Y though. The Y will print no problem. All right. So this here again, the magic number is 45. So 45 degrees. So if you go to make the Y, as long as the Y is 45 degrees or steeper, this will be able to print. If you're looking at the Y, it's going to be able to print layer by layer, and it's going to work out just fine. All right. So as you design your models, the number one rule is you want to try and avoid these sort of overhangs. So think about how your model will be printed. Think about, look for overhangs. Think about how you can sort of redesign your model to avoid those overhangs. There's a few things we can do to fix this. So imagine I need to print it like this, right? In this particular case, the easiest thing that I can do is change the orientation of my model. So I can say, I want to print it like this. And this here, if you notice, there's now no more overhangs just because I changed the orientation, and this will print just fine, all right? Easy fix here, not always that easy. One other thing that we can do is we can tell the printer to use support material. So I can turn on supports, and if I slice this, all this green stuff here, this is all support material, all right? So what that does is after you print it, you can actually break this off and just throw it away. You want to try and limit the amount of support material you use though, because one, you're wasting material, you're just wasting filament. Two, it adds a lot more time to your print. So this added about an extra hour or so to our print time. And three, when you do take this off, you can tell where there was material, and it just doesn't look as nice. It looks a little bit rough on the edges. It's just not as pretty. So if I were to do this, the Y would look really nice. The T and the H would have sort of more of a rougher surface to it. All right. So again, we can do it, and usually it's sort of like a last resort. And using a little bit of support material is okay, but sometimes, like the way it's designed, it can double the time it takes to print, and that's what you want to avoid. As another example for you, I have a model of Yoda. We all love Yoda. All right. So if I want to look at this one here, notice my ears, these are overhangs. And if I were to try and print this with support material on, you'll notice it's going to add a lot of that extra support material, which would then need to be taken off. Look at all that, right? All over the face, all over the ears. That is not ideal, all right? Now, it's not like the other one where I can just sort of flip it on its side and it'll fix the problem. There is one last workaround that we can do if needed. So I can take Yoda, I'm going to rotate him like this. I'm then going to slice him in half. So what I can do here is I'll take both Yodas, I'll put the flat sides on the bottom, like so. And if I now go to slice this, and the printer looks for overhangs, notice there's a lot less of green support material having to be used. So that's going to cut down my print time significantly. And what we then can do is, after this print, we take the two pieces, put some super glue on the flat parts, stick them together, and as long as you sort of line them up well, you almost can't even tell it was ever two pieces. And this is what a lot of people do. If they try and print a really large part on a small printer, they may need to slice it into like 4 or 5 pieces and then just glue them back together after the fact. All right? So this is another option. The best thing, though, is to be mindful about your design and try to avoid overhangs whenever possible. All right, so that's all. If you have any questions, come talk to me in class. Thanks for watching.